resolve another technical problem. Okay, I was saying about the Killingworth type of locomotive. You can see there 2 cylinders set into the crown of the boiler, with the vertical piston action, pushing the crosshead and in turn moving the connecting rods to rotate the wheels. You can rebuild an engine on a number of occasions, but each time you rebuild an engine like this, you would retain the wheelbase exactly as it is. If you change the boiler, you'd have to put the cylinders back in the same place. If you change the frame and the wheel sets, you'd have to do likewise, maintain that wheelbase. So Billy, therefore, has been through clearly a whole range of alterations during its working career, but the wheelbase would have remained as it always was, 6 feet 4 inches. And from that, I deduced that this was indeed one of the locomotives first built in 1816. So that poses the problem, therefore, that what did the locomotive look like when it was first made, and how was it altered during its working career to finish up in this form? So let's have a look at what we think the first locomotives that worked on the Killingworth line looked like. This is a drawing that was published on a couple of occasions, clearly depicting a Stephenson patent engine. You can see there that I highlighted the plaque on the side of the boiler that was depicted by the artist, and I've highlighted that, and it says Stephenson's patent locomotive steam engine, clearly referring to the 1816 patent. So here we have a loco that, okay, it's in the Killingworth type format. We've got 2 cylinders set into the crown of the boiler. We've got an iron frame, very light frame, on top of which are 4, taking the 2 sides, 4 steam springs, which of course were part of that patent. The wheel sets were combined by the use of a surging chain, to use the term that they used, a surging chain. So that's the locomotive as it first was constructed. But very soon, a number of alterations and improvements were made, which we will follow through in the trail of how it got from looking like this to how it looks as we see it today. So the boiler itself is 8 feet long and 3 foot 9 inches in diameter, through which runs a single flue of 20 inches in diameter. So the first alteration that was made in the early 1820s was to increase the size of the wheels from 3 foot diameter to 4 foot diameter. Now, Nicholas Wood, in his treatise of 1825, tells us all about this improvement and how it benefited the performance of the engine. Subsequently, the locomotive was reformed at the Robert Stephenson Co factory here in Newcastle. This, I should say, some of the Killingworth locomotives were reformed at the factory, and almost certainly Billy was amongst them. The steam springs were removed and replaced by plate springs. The plate springs were first used on the Killingworth line in 1827. They were first fitted to the vehicles, the wagons. They worked successfully, and so they then tried them out on some of the locomotive fleet on the line. And therefore, it's almost certain that Billy would have received the spring set at some time in the late 1820s. Also, the surging chain has been removed and replaced by coupling rods. Now, the instigator of these alterations was almost certainly Nicholas Wood, because by this time, George Stephenson had moved on, and although he never lost his interest in what went on at Killingworth, nevertheless, Nicholas Wood played a day-to-day role and was almost certainly the instigator of these improvements. But she carried on with her same boiler. The next alteration that took place was shortly after 1830, because here in Newcastle, the Robert Stephenson factory, they not only did they successfully win the Rainhill trials, but they also carried on developing the mainline locomotive, including the introduction of the sandwich frame, which was so much more robust than that light iron frame that we saw earlier. And all of the Planet class locomotives that operated on the Liverpool and Manchester Railway were fitted with sandwich frames. They were robust and made of oak or ash, plated on either side with wrought iron plates, hence the sandwich. And so it's interesting that when we came to, when Peter and I carried out a study 3 or 4 years ago, and Peter joins us this afternoon, so we'll be able to speak with him later. We saw that the framework on Billy is of a sandwich frame type. You see there the bulk of timber, the oak, and on the outer side is the plate of wrought iron, and on the inside there is a similar plate, but there are angle irons instead of ordinary straight plates. And in the lower photograph, you can see one of the stretcher beams going across the midpoint of the locomotive. And again, it's made of an oak beam plated on either side by wrought iron. So that means that the frames that we now see on Billy date from the early 1830s. One of the odd things we noted at the rear of the frame is a hole. Holes are fascinating when you come to look at engines, because the hole is only there because you put it there, and you put it there for some good reason. This is a 3-inch diameter hole, and is in fact the hole for the to allow the water pipe from the tender to pass through to the end of the boiler cylinder itself, so that it could be injected into the boiler itself. You can see there, going back to the previous picture that we saw, the vertical action of the boiler feed pump, which was activated by the crosshead moving up and down. So this picture shows us that the water feed pipe was on the left-hand side of the loco, as is the hole in the frame that we now see. So that serves to explain what that hole was doing. The next thing we noticed from the records of the Robert Stephenson Company is that they took in more locos from the Killingworth Colliery, including almost certainly Billy. It's just that they never identify which particular locos they served, but almost certainly was. And the boiler was reformed. That 20-inch flue that was ran through to start with was replaced by a similar diameter flue for the firebox. There was a round or slightly oval firebox. And at the halfway point, the tube plate was inserted, and from the halfway point to the leading end of the locomotive were a nest of tubes. So the leading plate was a flue plate, and in advance of that, of course, was the smoke box upon which sat the chimney. So although Billy carried on using the same boiler cylinder, the technology improved enormously, taking advantage of all that had been learned at Rainhill and afterwards, and a whole series of tubes were inserted and increased the heating surface no end. So the only other alteration to point out is the wheels. The original cast iron wheels were very vulnerable to breakage. They broke several times. Timothy Hackworth introduced the 2-part cast iron wheel, allowing the outer part to be replaced without needing to take the whole wheel off the axle, which was very time consuming. So they could take off a cracked rim and replace it with a fresh rim much quicker than they could change a complete wheel. And so this answered one of the main criticisms of the earliest wheels supplied by the Stephenson Company and others. Also, I've added at the back here a tender. This is a photograph of the tender that remains with Billy and is itself a very historic vehicle, arguably the oldest tender to survive anywhere. Not necessarily coupled with Billy, but it doesn't matter, they belong to the same era. So here then is a view of what we think Billy looked like in, let's say, the mid-1830s, following the introduction of those alterations that we've just been through. But when Peter and I examined the boiler, then we found a boiler of a different era. This was not the original boiler, it had been replaced. And a boiler of this type would almost certainly belong to the late 1840s. You see there it has three-ringed boiler, and the boiler itself is not only longer, but it is also of greater diameter. It's 10 feet long and 4 feet 3 inches diameter. So that was interesting because that posed the problem, well, who made this replacement boiler? It's quite possible that the boiler was made on Tyneside, possibly by the Coulthard Company of Gateshead, who specialised in the provision of railway equipment for collieries and colliery railways. So we were able to examine the boiler in some detail, and this is the first of a number of splendid drawings prepared by Peter, which make understanding of the locomotive so much easier than just looking at photographs. You can see there a cross-section of the current boiler. It is much along the lines of what I was just explaining, how it had been reformed originally in the 1830s, but as I say, this belongs to the 1840s. Now, this type of boiler I've come across on a number of occasions because it was a typical industrial engine boiler, a round firebox, or actually, to be more correct, an oval firebox, which acted as the fire grate, the firewall, and a combustion chamber. Then there comes the tube plate, and then in advance of that is the nest of tubes feeding through to the front tube plate. You see there the spaces where the cylinders were inserted into the crown of the locomotive, and this type of locomotive worked very successfully in industry for many a long year. The boiler was supported by brackets fitted to the frame. The feet of the brackets were bolted through the frame, and the upright of the bracket was curved round the boiler, and you can see that it was bolted into place. All four brackets were bolted into place, which means there was no expansion slide at all. Every time the boiler was used, it must have been a bit like a banana wanting to bend. And so stresses were set up in the bolts and the holes of the bolts. And there was evidence in Billy that two of the brackets had set up stress fractures in the plates along the side of the brackets. On the right-hand side picture, you can see a look inside the boiler. The front right bracket has been hatched. Just see at the bottom there the patch. It could only have been fitted by removing the tubes and the front tube plate to gain access to it. And there is evidence again in the archives of the Robert Stephenson Company that locomotives were taken in and repaired in the 1860s. So this is probably the work of the Stephenson Company that carried this out. The other bracket that had a stress fracture was the left-hand rear bracket, and this almost certainly was carried out, the repair was carried out by the men at Killingworth itself, because it was not such a neat job as the one you can see here. It was, they removed the bracket, they relocated it further back, and really it was a make, do and mend job, probably allowing the locomotive to continue to work under lower pressure at Killingworth for a few more years. This make, do and mend approach was quite common on the colliery system because money was always at a premium. Here we look inside the fire grate, the fire box at the fire grate. You can see there the crown has been depressed, which would make any fitter depressed, I should think, because that would almost certainly have taken it out of service once and for all. In advance of the fire grate, you can see the wall, and beyond that is the combustion chamber, and then you have the flue tube. There's a close-up of the tube plate. Now, I'm not the most athletic of people, so I didn't volunteer to go in and take this picture. But Peter, who's a lot fitter than I am, he did volunteer and went through and took this picture, which is rather splendid. Here's a close-up of the tubes, clunked into place, as they called it, using anyway. Right, so now we're looking through into the boiler, through the inspection hatch. The inspection hatch was fairly easy to remove, but we had the assistance of the team at the museum here in Tyneside, and we were able to see inside the boiler to understand better what's going on. So here is an external view of the firebox, at the front end of which is the tube plate, and then of course you have the nested tubes that are passing beneath where we're photographing. The two rods are both stay rods from one end of the boiler to the other. Now, another of Peter's splendid drawings is the boiler in plan view, showing first of all the openings for the two cylinders inserted into the crown, and between them is the hatch cover, or that is the hatch, which was covered. That was removed to allow us to lean inside. The regulator handles are also shown here, because the regulator could be operated from two locations. Firstly, on the footplate, and secondly, on the left-hand running board. Now, it was the tradition on the Stephenson locomotives to drive these locos from the left-hand running board, but from time to time there would be occasion for the driver to stand on the footplate, and so the linkage allows both regulator rods to be operated from those respective places. And in between there is the fulcrum, which operates the regulator mechanism, regulator valve mechanism. Again, looking inside the boiler, Peter and I feel very privileged to be able to see inside the boiler of such a very early locomotive. Here is the leading cylinder protruding down through the crown, and just in front of it is the steam access line through to the steam chest above the boiler crown itself. And you can see there it is segmental in shape, and the segmental valve itself is open to the left, to its left, and by moving the regulator handle, it rotates around the fulcrum there to open or close that regulator valve. Another look at the mechanism for doing that. There is on the top left photograph is the hatch opening. from which we were just taking that photograph. In front of us is the regulator handle for the left-hand running board. The top right photograph is the regulator handle for the operation from the footplate linked through. And the photograph at the bottom is the pivot from which the mechanism is rotated by the handles and linked through to the respective valves openings, the regulator valve openings. So it's a very simple linkage through, but it works out well. Above the boiler is, of course, the top part of the cylinder and the steam chest and its valve. You can see there the passage that I'm going to actually try and point this out to you because just there, that's the steam passage where the steam's coming up through that opening, the segmental opening we saw earlier. It passes then into the steam chest here, and the steam is then distributed along the internal passages there, with the valve reciprocating through in normal way. Look at the cylinders themselves. Now, the cylinders that we now see on Billy are not the original ones because the flanges fitting it to the boiler crown were made for a boiler of 4 feet 3 inches diameter and not for the original 3 foot 9 inches diameter. But nevertheless, the two cylinders are asymmetric. You can see there the cylinder covers are of different castings. So one of them perhaps was an original fitting on Billy, but the other one perhaps was transferred from another of the locomotives that also had a boiler 4 foot 3 inches diameter. So with the kind cooperation of the staff at the Stephenson Locomotive Museum, we lifted the cylinder covers and peered inside the cylinders themselves to see not only the interior to see if there's any irregular wear that's been set up, but also, of course, to see the pistons inside. What we see is an interior view of the cylinder. Here is the steam passage exit, and at the bottom is the top end of the piston and its piston rod. Inside the steam chest, you can see the top photograph is the valve itself, cast iron, that reciprocates up and down according to the motion. And on the bottom photograph, you can see the top end of that segmental steam passage, bringing the steam in from the boiler into the steam chest itself. Now for the valve gear, always a tricky topic. The drawing, Peter's drawing in the top left there, is divided between the side view and an end view of the valve motion. You can see that the motion is driven by an eccentric on the driving axle, one for the leading cylinder and one on the rear axle for the rear cylinder. The eccentric is linked by an eccentric strap and eccentric rod to a bell crank that operates the lower rocking shaft. The lower rocking shaft transmits the movement through to the long vertical valve rod that's driving the upper rocking shaft. In between, there are, of course, the transverse rod, the actual rocking shaft itself, which can be detached from the vertical shaft by the driver when he seeks to alter his direction. It looks complicated, but actually the driver's got adept to lifting that lever, or lifting the vertical rod off the lever, moving the valves by hand, and then relocking by the vertical rod. Bottom left there is the eccentric itself. You can see the eccentric clamped to the axle and the dog protruding into a gap into the side of the eccentric itself. The eccentric rods have been removed, and they are in the third photograph on the right there. This is to make it easier to move Billy around any museum site. So they have been kept, but they remain detached. The second photograph is of that lower rocking shaft, and the last photograph on the bottom right shows the vertical rod transmitting the rocking action from the lower rocking shaft to the upper rocking shaft, and it's cranked around the axle, around the boiler, because of course it would otherwise conflict with it. Now to the driving motion. There in the main photograph at the top there is the piston rod attached to the crosshead, the cast iron crosshead with a spherical end to it. This is a candidate for being a component that perhaps has outlived all the other components on the locomotive, but there is absolutely no evidence to confirm one way or the other what its date is. The crosshead slides up and down in the slide bars, and the slide bars are retained in place by the stays, the longitudinal stays and the transverse stay. And if you look closely at the transverse stay, you can see two holes in there. As I said earlier, if there's a hole there, it's there for a purpose. You have to work out what that purpose is. It's very easy, of course, in this case, because the chimney, which is now fitted to Billy, is ridiculous, absolutely ridiculous. It's far too short. Billy had a much taller chimney when in operation, and those two holes were for the stays to support that higher chimney. Bottom left, you can see there a detail of the clevis, which transmitted the movement of the piston and piston rod and lifted the crosshead. Then there comes the photograph of that spherical bearing, the spherical end, with a lower bearing fitting in place, and on the bottom right is the upper bearing for the ball end turned upside down. So again, a real privilege to see some of these very, very early locomotive features that, of course, went out of being in so many years ago. Now we come to improvements to the frame. The front end of the frame was extended in the 1860s. In fact, there are a number of alterations date from the 1860s, and they may very well have been carried out at the same time. But just to keep the locomotive going, these improvements were made. The original frame ends in, that's the longitudinal frame, ends in the centre of the photograph. I can't point here. That's the original longitudinal frame that was ending there, and similarly there. And this beam was added to it and extended out on this side of the beam. And on the face of those beams was the buffing pads, just here and here. Now the buffing pads were to suit the improvements that they made in the wagons that they employed on the Killingworth Colliery. They were faced with wrought iron plate so that they didn't suffer too readily with all the banging and crashing in the shunting. In the centre of the beam, you can see the draw hook in the top right-hand photograph. The draw hook was fairly substantial, draw hook and chain, and on the inside of the front beam, the draw hook is coupled to a volute spring, which you can see there in the bottom right-hand illustration. Now, volute springs haven't been, it wasn't possible to make them too early in the 19th century. They started to be used in the mid-century for other parts of locomotives, but for this purpose, they were introduced much later. Whether or not that spring was inserted when the locomotive was in service, or whether it was fitted after it came out of service, is not possible to say. But what it does indicate to us by the sheer strength of the draw hook and the spring is that Billy was employed backwards, hauling its load from the colliery to the Tyne. Always under load, it was running backwards, therefore always facing west. So when it drew the empties back, of course, it simply ran round and ran forward in the middle of the road. So we come down to the 1860s, following the various alterations that were made. You can see there this is a photograph that's been turned into a montage, if you like. It shows a real photograph of Billy's boiler, but I've used it for this slightly earlier vision of Billy. You see the boiler there, the larger boiler, 10 foot, 4 foot 3, a much taller chimney, stayed to that to the crosshead stays, retaining its the buffer beams at the front end that we saw earlier, and also retaining its two-piece cast iron wheels. We know from archival evidence that these wheels were continued to be adopted on Billy for much of its career. And once again, tacked onto it is, of course, that wonderful timber. And you'll see also the number 1 painted on the side. And that's quite an interesting point when it comes to identifying and confirming the identity of number 1 in the Stockton and Darlington fleet. In the Killingworth Colliery fleet. Stockton and Darlington. Right, now then, following that, the wheels were subsequently replaced. The wheels that are on there now are slightly smaller than the 4-foot wheels. These are 3 foot 7 inches in diameter, H form, so a much later period of wheel making. They are of cast iron. The axle that you can see there is the leading axle on Billy and has been machined, which raises the question, why has it been machined? The answer is we don't know. We've been speculating as to whether or not it was one of the earlier axles has been redeployed, or perhaps it came off another machine entirely. It's very difficult to say. There's arguments for and against, but nevertheless, it is a very interesting feature, is that machining on the leading axle. The one subject we haven't covered yet is the exhaust pipe, because it's the exhaust pipe that gives the game away when it comes to identifying the locomotive. The museum had thought that the locomotive had been made in 1826 because of an illustration of another locomotive that was very, very similar, and it was published by Samuel Smiles in this story of George Stephenson. The fact of the matter is that the exhaust pipe sits on the right-hand side of the boiler centre line, whereas in the picture that I've just mentioned of that other locomotive, it sits on the left. You cannot change a big cast iron exhaust pipe from one side to the other. It doesn't make any sense. So this serves to illustrate the uniqueness of Billy. You can see there the top left photograph is where the exhaust pipe starts, leading out from the rear cylinder. Bottom left is the run of the exhaust pipe along the right-hand side of the boiler. The bottom right photograph is where the front exhaust pipe joins the main exhaust pipe, feeding through to the smoke box, turning down into the smoke box, and then on the inside of the smoke box, it turns straight back up again to exhaust through the chimney. There is this top left, there is this coming through the crown of the smoke box and turning straight up into the chimney. There on the bottom left photograph is a picture of the chimney sat on the smoke box with a pipe leading into it, which was the blower pipe, which had clearly been from a much later era, and also a photograph there of the chimney. Now, I was rather rude about the chimney, and I continue to be rude about the chimney, because it doesn't look anything like that which was ever used on Billy. And it was winked from every time I look at it. Now we come to the footplate. There on the footplate are two large boxes. These are sand boxes, always an important characteristic of any locomotive used in the coal industry, because getting a grip and starting a train of coal wagons off is all important, particularly on an icy day or a wet day. The bottom left shows the cover removed and a pipe inserted. Now, this pipe turned out to be an old boiler pipe, which is extremely useful because that served to tell us a lot about the pipes that were used on Billy. What the fireman was required to do was to have a scoop, to scoop the sand and put it down that pipe. And in the bottom right-hand photograph, you can see, if I can point it out, you can see the pipe coming beneath the footplate, just above the rails. The sand dropped on the rails, and as the train was going backward, hauling its load, it took advantage of the sand on the rails. Right, now we come to photographs. This photograph is fairly well known. It was taken almost certainly at Killingworth. There's just no catalogue description that is positive that it was Killingworth. I believe that it was taken just before the locomotive left Killingworth in 1881. So to explain, the loco was taken out of service in 1879 and was, as so often happened, just kept, not thrown away or scrapped, just kept. And in 1881, there was a major occasion here in Newcastle on June the 9th. This was the centenary of George Stephenson's birth. And the whole of Newcastle and Gateshead was en fête for the day. There were speeches and marches, there were dinners and lunches, there were everything. And there was a gathering of historic locomotives at the infirmary sidings, just adjacent to the central station, just to the west of the central station. And Billy was driven down, we are told in the newspaper reports, Billy was driven down in steam down to, first of all, to Gateshead, and then across to the infirmary sidings. And I think this photograph, which is absolutely splendid because it's got such wonderful illustrations of the men themselves that had been responsible for Billy's well-being. And it's a lovely study of these work-hardened men. So there is Billy just before 1881. In 1881, there is the locomotive photographed, as we've seen pieces by component on previous slides. This was taken in the infirmary sidings by Bleasdale, R.H. Bleasdale. He took an awful lot of photographs of early railway scenes, especially locomotive scenes, and he's handed down to us this wonderful archive, including this of Billy. There it is. That's how it got from how it started and went through all those rebuildings until it looks like this now. As you notice, number one, it was Killingworth Colliery, number one. When Charles Palmer gave it to the good people of Newcastle. They expressed all sorts of words of gratitude in the press, and then didn't know what to do with it. It was an embarrassment. They hadn't got a clue. Where do we put it? They had committees and subcommittees and all sorts of agendas to try and work out what they could do with Billy. And they were embarrassed. And they were still arguing up until 1883. And various schemes had come and gone, but it was still presumably in infirmary sidings. Can't imagine what else they did with it. And then they got a letter from someone living in, of all places, Chicago, in Illinois, United States. They were going to put on an exposition, as they like to call it, an exposition of railway appliances. And somebody from Chicago had been to Newcastle in 1881 to see the gathering of early locos and all the other, all that went on that day to commemorate George Stephenson's centenary. They went home with this vision of Puffing Billy. Have you heard about Puffing Billy? And that's what they called this. Not they heard Billy and assumed it was Puffing Billy, which of course it wasn't. Puffing Billy has always been on display down in London. So they asked if Puffing Billy could be made available to attend this exposition in Chicago. Well, the city fathers of Newcastle thought that's a good way. It means we can stand down from trying to find where to put it, because we will send it across to Chicago. So in a very, very short time, they got it ready to ship out to Chicago, but it was way behind all the other exhibits from Britain. It got there only just in time for the exposition. In fact, only a few days before the exposition ended. So after all of the efforts, can you imagine the efforts to ship Billy out across the Atlantic to the Atlantic seaboard of America and then ship it by rail all the way across to Chicago? And then, having put it on display for 2 or 3 days, and incidentally, I have never, in spite of looking so hard, I have never seen a picture taken at the exposition with Billy in place. And that is one of those ambitions. And I was excited when talking with John Clayton just a little earlier, that he thinks perhaps he's seen a picture in Chicago. I look forward to seeing that, John, if ever that was possible. Anyway, as soon as they got there and put it on display, then the exposition finished, and they packed it up and shipped it all the way back to Newcastle. But when it got back here, the city fathers still didn't know quite what to do with it, and so they decided that they would actually put it up on the plinth on the high-level bridge. And that's what they did. At the end of 83, or just possibly January of 84, they put it on this concrete plinth on this side at the time in this transverse presentation. A photograph was taken, and I've only just in the last few weeks seen it, with the name Billy on the side. Billy never ever carried a name during its working life. That was a nickname. But there on the side is Billy as a name. So somebody put that on at some stage during its time on the high-level bridge. It meant, of course, that anybody travelling by train from the south across the bridge would have to see Billy standing there. So it became a veritable icon. But here comes the bad news. By the time we get through to 1896, Billy was in a terrible state, out in all winds and weathers, up high on the bridge. There were so many chemical factories on Tyneside at that time that the air was seriously polluted. When it rained dilute sulfuric acid. And this acidic effect meant that an awful lot of billy was starting to corrode and decay. Somebody wrote into one of the newspapers to say how disgraceful this was, that an icon like billy should be treated in this way. And everybody was embarrassed. And so the North Eastern Railway decided to take action. And with the agreement of the city fathers, they took billy down, took it across the Tyne, and took it into the workshops in Gateshead, the North Eastern Railway workshops, to try to return billy to something approaching more the appearance of what we expect an icon to look like. When they'd finished, they didn't take it back to the high level bridge. They put it on another plinth, but this time on the central station platform. Platform 9 to be correct, or what was then platform 9. And here is a photograph taken shortly after it had been unveiled. Now, the North Eastern Railway did, I'll say a good job, but in fact they did too good a job. Because, for example, the cladding had deteriorated and they removed that and threw it away. And they put their own cladding on. No ordinary metal cladding, no ordinary deal cladding. They put on mahogany cladding. Now, can you imagine billy in the days it operated at Killingworth, operating with mahogany cladding? That would be laughed at. Because they ever had access to mahogany at that time. In addition, the smoke box and the chimney were taken off and replacements were added on. So what you now see there are replica smoke box and chimney. And hence my comments about the ridiculous chimney. This is quite inappropriate. Some of the woodwork also had to be replaced as well. But there it stood on platform 9 on the central station for another, until 1945. So what's that? That's 49 years, just under 50 years. And then it was taken down because the platform was to be reformed and widened to allow for an increase in the number of trains using the central station. So that is the story of the billy itself. It was taken to the Palace of Arts building in Exhibition Park, and there it remained until 1981, where I first saw it. And in 1981, it was removed from the town moor through to the Metro Test Centre, which by that stage had been taken out of use. That in turn became the Stephenson Railway Museum, and that opened in 1988. And billy has been on display at the museum since that year. And since the report that Peter and I prepared about the loco, the whole of the presentation at the Stephenson Railway Museum, I'm told, has been significantly improved to incorporate some of the new facts that we have been able to make available. That's not quite the end of the story, because we have to come back to the tender. There's this wonderful tender. It really is a splendid vehicle. It's a timber-framed vehicle. It belongs to almost certainly the 1830s. Whether or not it ever was paired with billy, in a sense, doesn't matter. It is contemporary. It has a wrought-iron tank fitted to the upper surface. You see the top left picture is the filling hole and cover and gap. The second picture is the tap to open up the discharge tap at the bottom of the tank, so that rod runs all the way through the tank through to the discharge tap, which is in the top right on the photograph. The bottom left shows the rear end of the tender, with a much simpler, lighter fitting. None of the strong draw hooks and volute springs that you saw on the front end of the loco. So this indicates that it was used in the forward direction for the purposes of drawing the empty wagons back from the Tyne back to Killingworth. The centre bottom photograph is the void, huge void underneath the tank, showing the wooden frame structures. And the picture on the bottom right is the coal space that was used. Well, that all sounds fairly straightforward, but now comes the problem that Peter and I had very, very great difficulty in understanding, because the top main photograph shows Bleasdale's photograph taken in 1881. And just have a look at those wheels, star form wheels. Quite normal, quite understandable use of that cast iron wheel arrangement. Now have a look at the wheels at the bottom, the wheels that are on there now. They are not the same wheel sets. They are substitute wheel sets, and they are fitted to an octagonal axle. Clearly a make do amend arrangement, because the journal of the axle is for a 3 inches diameter, whereas the bearing for the wheels is 4 inches. So quite clearly not made to match at all. But just have a look at that, at the spokes. The spokes are quite different and quite unusual. And for a long time, Peter and I felt that this perhaps had been altered in America. But we now understand, as a result of, we spoke about it on the at the Early Rowers 7 conference this last June, and a member of the audience there said, "I have got a photograph of the North Eastern Railway coal wagons with that form of spoke." And bless him, he did turn it up, and we could see that this form of spoke had been used here in the northeast of England at some stage in the 19th century. So that meant it did come from a northeastern cast iron factory. The name of that factory is embossed on the outside, the bottom right photograph. You can see there is embossing, almost certainly saying the name of the foundry. But do you think we could read it? We looked at it from every angle and tried to read what it says, but without success. We could not match it up with any foundry. If anybody's got nothing to do for an afternoon, go and have a look at Billy's wheel sets. Have a look at those words, the foundry name, and see if you can work out which foundry cast these wheel sets. And that really is the end of the story. Thank you very much indeed for your attention. Could I just add that I'd like to express thanks certainly from John Clayson and his colleagues here at the museum, the Discovery Museum, and also to Robin Gibson, who was then the Railway Operation and Engineering Manager at the Stephenson Railway Museum, who was so very, very helpful to us during the course of the study. And last but by no means least, could I say a very big thank you to the sponsors who paid for our expenses during the course of the study, which made the study possible. Without them, this study would not have been possible. So a big thanks to them. Thank you. We're pleased to answer any questions that anybody may have. And Peter will join me, if you will, to answer any questions that may arise. Oh yes, John Suter has just asked me to explore with the Zoom audience, use the chat facility and just send them in. He will pick up the questions as they come through on the chat facility, and I will seek to try and answer them, or Peter, to the whole audience, both you on Zoom and also here in the room.
Hi, my name's Nina Baker. My question was about the wheels. In the very first pictures you showed us, they were really slender and elegant and really unfeasibly thin, especially in the spokes. But nothing you showed us later, let alone the photos, looked anything like so thin. Were those first drawings just ridiculously idealized?
Sorry, I found great difficulty in picking up what you were saying. Is it possible to put it into words? Because the acoustics in here wouldn't allow me to pick that up.
Do you want me to speak again?
Well, try, if you could go just a bit slower so I can pick up the words. So the acoustics are not good.
The first drawings you showed had very slender, elegant wheels, but nothing you showed us later was anything like so elegant. Were those first drawings just idealized to the point of almost absurdity, or were they really so slender?
Right, okay, I got it that time, thank you. The casting of wheels at this time was extremely difficult, and they were constant failures. The difficulty was getting a good bind at the end of each spoke with the ring. As it shrank in the mould, it tended to pull from the spoke from the ring itself, and that was a weakness that they had to struggle with. Eventually, they did try different kinds of casting. They used borax, I seem to remember, in the casting process to try and give it some additional binding strength. And it worked up to a limit, but such was the standard of track at this time that the locomotives, as it was going along, were subject to severe dynamic forces as the locomotive moved along the track. And therefore, there was that tendency for one wheel to be up in the air and the other three wheels to be on the track. And then suddenly the loco would lurch as it went over the hill, so to speak. And that caused that severe dynamic force, which very often cracked the cast iron wheels. So you asked about how slender they were. Okay, the illustrator may very well have slightly overdone that, but we have no drawings, no details of the dimensions of the spokes in relation to the wheel itself. But certainly they were very vulnerable indeed.